We're going to look now at sedimentary rocks, and essentially sedimentary rocks are rocks that are made out of cemented sediments. Now sediments are broken down pieces of either other rocks or, as you're about to find out, dead stuff, organic material. So here's the three types of sedimentary rocks. We're going to look at clastic, organic and chemical. Now clastic are the ones that you would most readily identify as a sedimentary rock, because it's quite easy to see in clastic rocks the remnants of broken down rocks of different sizes, and we'll have a look at them in a minute. Organic sedimentary rocks are essentially made out of dead stuff. Now this could be dead animals, it could be dead plants, which have been covered and as they decompose over time and form organic rocks. Chemical sedimentary rocks are made out of dissolved material. So essentially this is minerals from previous rocks that have dissolved into water, and then as the water is evaporated, the chemicals from those minerals have deposited into sediments and formed a different type of rock called chemical sedimentary rock. First of all, let's look at clastic sedimentary. These are the ones where you can easily see the broken down pieces of rock. Here is a very good example. This is conglomerate. As you can see, this is rock that's made out of smaller pieces of rock all cemented together. Large and small pieces of rock, not just one size. Notice how all of this rock here is quite smooth on its edge. These are the types of rocks that you'd find in rivers where they've been rolled over by the water and all of their sharp edges have been worn and weathered away. These smooth-edged rocks are the types of rocks that you find in conglomerate rock. In contrast to conglomerate, we now have breccia. As you can see, this is cemented together rock as well, but all of the edges and angles of this rock are quite sharp, and that's because this rock has been broken up and then cemented together, but it hasn't been exposed to weathering that smoothed its edges before it was cemented back together again. So this is what we call breccia. In contrast to conglomerate and breccia, there's an awful lot of rocks that are formed from very small pieces of rock, like sand. This is sandstone, and as you can see, if you look really closely, there are fine grains of sand that form this stone, and not just one layer of sand either. Over time, different layers of sand have been deposited down and then cemented together to make one piece of rock. And the type of sandstone it is, of course, depends on the colors of the crystals and the types of chemicals that make up the crystals that form the sand that cement together to make the rock. Now, even smaller than sand to make rock is something like mud or silt, and here we have an example here. This is claystone, and it's made when clay dries out and is compacted together over time with a lot of pressure, and it ends up cementing the clay particles together to form rock. Now there's quite a few different versions of fine-grained rocks like this. You'll hear about them. Claystone and siltstone are the most common that you'll hear. Now here's a little table to help sort all these out. We learnt about conglomerate, breccia, sandstone, siltstone. Now the last one here is shale, which I didn't get a picture of, which is essentially made from even finer particles. Now each one of these different types of rock are categorized depending on the type of grains that they are made up of. Grains are simply the broken down pieces of rock that they're made out of. If they're over 2 millimeters, we call that a very coarse texture, and they're the types of grains that go together to make conglomerate and breccia. Smaller than 2 mil, but still quite easy to see, is what we class sand as, and that of course goes in to make sandstone. Finer materials, which are extremely small, are classed as mud, and they go to form your siltstone, your shale, your mudstone. Now let's look at organic sedimentary rock. Remember, organic sedimentary rock is essentially rock that's made from compressed, decomposing, once living material, or dead stuff. Here is an example. This here is peat. Now this is found in Europe all over the place, and although it looks like mud, this is actually used to light fires and heat up houses in England and Scotland and Ireland. Peat is essentially dug up from swamps. It's made out of plant material that's been covered over, and as it's been decomposing, it hasn't been exposed to air. So the type of bacteria that would normally break down the plant material couldn't survive. As it's decomposed into something slightly different than we would see if it was on the surface, and it ends up becoming this black material, peat. Now, if this decomposes for a lot longer and is put under a lot of pressure, peat turns into coal. It is essentially decomposed plants covered up by mud or other types of materials, so that when they decomposed, the air wasn't able to get to them, so they didn't break down like we've seen materials normally breaking down on the surface. So it could have been a small forest that's actually been knocked down or blown down or covered by a mudslide, and the plant material, as it's broken down, has been eaten up by bacteria that don't need oxygen in order to survive. And because of that, it turns into coal. So this is evidence of a fossilized forest. Chemical sedimentary rocks form when dissolved materials reform into rock. So say you've got a creek bed, like I said before when it came to conglomerate. Conglomerate rocks are smoothed down as the rocks are churned over and knocked over in the creek bed, and all of the edges are worn off as they break and smash together. That means you have dissolved material in the water. Now on top of that, you can also have the remnants of marine life. So everyone has seen little shellfish and other type of little organisms in the water. Now those shells are made out of calcium carbonate, and when the shellfish die, the shells will actually dissolve into the water as well. And those remnants of those shells are extra minerals that the water will actually hold. Now that's fine and will stay like that until the water begins to evaporate. As the water evaporates, the minerals that are dissolved into the water start to get more concentrated. And as they do so, they start to then form sediments on the bottom. Now these sediments then start to form very small crystals, sometimes large crystals if they're given enough time to organize, but they precipitate, which means they become solid again. Now, if this happens quite slowly, these can become crystallized and form crystals. If not, they form really fine crystal sediments that don't look very much like crystals until you look at them more closely. And in the end, you end up with a solid mass at the bottom that was once dissolved rock or dissolved shells, and it's formed a new type of sedimentary rock. And here's some examples. Stalactites and stalagmites are the leftover minerals of dissolved rocks. Then as the water has evaporated, it's recrystallized to form these beautiful formations. We often see these in caves. As water drips down through the roof of the cave, it dissolves rock on the way down, and as it then drops down to the floor, the water will evaporate, leaving minerals behind, which form these beautiful stalactites and stalagmites. Here's another one up close. As you can see here, there are very small crystals in these stalactites. Not all of them are easy to see, but it is recrystallized or precipitated minerals. Here's another example. These are the White Cliffs of Dover, and essentially this is what we call chalk or limestone. These are formed when the dissolved shells and the dissolved skeletal remnants of marine organisms fall to the ocean floor and precipitate, forming layers and layers of this solid calcium carbonate that you see here. So essentially this piece of land here used to be on the bottom of the ocean. It's been pushed up to form land mass here, but this calcium carbonate here used to be dissolved remnants of shells and skeletons. Now remember before how I said organic sedimentary rock and chemical sedimentary rock often go together. Here's an example. This is calcium carbonate in here and sand, and you can't really see the crystals because it's been deposited quite quickly, and it is actually cementing together shells that have been on the bottom of the ocean floor. So essentially we have organic material here cemented together by chemical sedimentary rock, which was once dissolved shells itself. So to sum it all up, sedimentary rock types. Clastic is made out of broken down rocks, broken down pieces of rock cemented together. Organic is made from accumulated biological debris or dead stuff. Chemical sedimentary is made from dissolved minerals, from either rocks or from shells and skeletons, and it's precipitated out again to form very small crystals and sediments. And that is sedimentary rocks in a nutshell.